There's an on-off button on the side. Okay, I need help here. I mean, here in and okay, so starting again. First of all, I wish the organizers for inviting me. I cannot stop myself also to say that I have a home Boulder connection. I started here in Boulder more than 30 years ago, first working in the research group of Jeff Linsky. I hope you were happy with my performance at the time. Yes. Doing stellar activity and doing investigations of objects like Arcturus and Betelgeuse. I didn't even know whether the sun existed. It could have been fake news. But I was actually informed otherwise when I joined HAO 3 years later. So I have very good positive memories about HAO. And yes, again, I'm very happy about this invitation. Talk about multiple stars in the sky, and I also will be talking about planetary habitability. Would like to say that I'm a faculty member at University of Texas, Arlington. Some people equate Arlington with Arlington, Virginia here, but we are talking Arlington, Texas. Arlington, Texas is situated in the Dallas-Fort Worth Metroplex. It's about 8.5 million people, almost twice the size of the state of Colorado. This keeps us quite busy. It's more like Los Angeles and Texas countryside. Also, what to say, Arlington is also known for Texas Rangers and Dallas Cowboys. Both of them play in Arlington. We are actually a small exoplanet research group with 3 senior members, Jiswav Musvilak and Suman Satyal, and some students. Even though we are small, we are covering a huge topic of study like exoplanets, exomoons, exocomets, exo, and so on, but studying formation, orbital stability, habitable zones, and astrobiology. So a lot of that is actually being inspired by interests of our students. And even though we are small, we have actually quite success in the community. What is the overarching motivation for studying exoplanets' habitability? First and foremost, it's really studying stellar and planetary properties. Regarding exobiology, important keywords are stellar habitable zones, stellar activity, study of terrestrial planets, and really noting that majority of stars, not counting mid and late M dwarfs, are members of multiple stellar systems. Habitability of multiple stellar systems is also relevant concerning Drake equation and Fermi paradox. And last but not least, we are very active with public outreach, which is actually spurred by the fact that we are centered at such a huge metroplex. There's a lot of public interest in the work that we are doing. So this is a standard diagram about exoplanets and exomoons. It stops at 2017, so I think there's new results. So what needs to be said, today there are 4,090 plus confirmed exoplanets, and I like the plus sign. That means I don't need to update this transparency. So that stays correct. And regarding exomoons, it says 0 confirmed. There is one controversial case which has been discovered, or type of discovered by Kepler, which is still part of ongoing discussion and controversies. It's also important to relate that topic to factoids of the Milky Way. I already said most stars in the Milky Way are members of binaries, not counting the coolest M dwarfs. And there is also the discovery of higher order
stellar systems like triple systems, quadruple systems, and I will talk about those during my talk. And based on information available to me, the record holder are two septuple systems. And want to say one of them may be controversial, may only have 6 stars instead of 7, but really what we know so far, this is our record. And another point of view about this, and maybe actually a smooth, debatable transition between multiple stellar systems toward gravitational bound open clusters. This is a topic of study for experts of orbital stability. Just like to mention this here. 2 suns in the sky, true, more often than you think. So obviously reason for my talk. And one of the points I would like to make at the beginning is to clarify some nomenclature, because regarding binary systems, there are 2 types of orbits. One is an S-type orbit, and the other one is a P-type orbit. Historically, S-type orbit was being said to be a satellite-type orbit, and the P-type orbit was being said a planetary orbit. But I want to say I don't like this type of characterization, because in any case, it's a planetary orbit. So we have 2 stars, and we have a planetary orbit. Maybe a better way of remembering this is that an S-type orbit is a case where a planet is orbiting within the stellar system by just orbiting one single star, as it would be a single star. And the planetary P-type orbit means the planet is orbiting both stars. There's a small story here. This terminology was actually coined by my friend Rudi Dvorak in 1982, and it was not published in a regular paper. It was being published in the minutes of a meeting conducted by the Austrian Academy of Science, and probably Rudi was actually concerned nobody would even accept that paper. So obviously that's a very, very unusual way of publishing scientific results, which is just publishing in the minutes of a meeting. So just want to say this. Background information, which is relevant here, is when we first of all talk about planets in binary systems, it's important talking about formation of planets, observational results regarding that, orbital stability analysis, and yes, stellar habitable zones. Orbital stability analysis is, of course, a highly theoretical topic here. With respect to observations, if a planet exists, it is orbitally stable, otherwise it wouldn't be there. So this is actually a very positive selection effect, but I want to say from the community doing orbital stability analysis, this is really a field which also has resulted in many, many papers in the past. So formation of planets, I have a few examples, and the first paper goes actually down in 1992. I probably can read it, so I have to go. Oh, don't want to mess around here or fall down this. Okay, so first one actually was done in the beginning of 1990, and the latest paper, which I just show here, was published in 2017, which actually shows a planet in the process of formation. I can also not stop myself. Want to say that one of my graduate students, Sarah Moorman, is actually using Martis in La Silla, Chile, to further that work, studying transitional disks and also studying planets in the process of formation around single stars, but also around binary systems. Regarding the study of habitability, I have want to say I'm talking a little bit about my own papers or papers of my group, but I really like to mention that there are many different players in the field, which I have listed here alphabetically. There may be other main players I have forgotten. If this is the case, I'm asking for forgiveness and mercy. So please feel free, write me an email. We'll update my slide for the next time. And so I want to say, very historically, this type of research actually focuses on the study either of S-type habitable zones of in binaries or P-type habitable zones. So historically, when this work was done, okay, historically, see a big word here after I've heard those previous talks. So I want to say until prior to 2014, so papers 2012, 2013, and so on. Yeah, had the tendency that the setup was, okay, you have to decide, okay, I would like to study habitability in an S-type system or in a P-type system, and then the work was done. And outcome was one way of the other. So I'd just like to quote some paper from Sigrid Eckel, from Lisa Kaltenegger, and Neda Hakikipur, who have done this type of work. So they're really good papers, also having a pretty high citation index. Another paper relevant to here was done by our student Billy Quarles, and he was interested in orbital stability studies of Kepler-16. What's relevant about Kepler-16? This actually was the first case where a planet on a P-type orbit was discovered in the binary system by the Kepler mission. Based on information available to me, what we studied in that context is the possibility of Earth-Mars planets and even Earth-Mars moons, and we identified a parameter space regarding Earth-Mars planets and Earth-Mars moons being possible. Climatology was also being done for CPP. What is CPP? Circumbinary planets. So that are planets in P-type orbits. So Pop and Eckel studied actually climate variations on hypothetical Earth-type planets in those systems. Again, work which is really expected, also relevant for the future. I have two slides which are focused on some configuration and statistical analysis. And maybe I go here to this. Okay, I have to take this to this other side. And one of the interesting points, and that's not actually type of unexpected, is so we have actually in this part some combinations of binary systems which are hosting planets. And as expected, I want to say, there is really a skew toward low massive stars. Not unexpected, because fact is, based on statistics, about 90% of the stars in the solar neighborhood are either M-type stars or K-type stars. M-type main sequence stars or K-type main sequence stars. So it's not unexpected, but on the other side, there's also still a significant case where planets are residing in binary systems where there are more massive main sequence stars. And another point here, for instance, that slide, I'm sorry if it's not very, if the resolution is not high enough, but also a typical outcome, and actually this is for P-type cases, this is for S-type cases. So in the P-type cases, what we find is that those planets are typically relatively close to the pair of stars. That's another interesting point. Again, a list of binary systems with planets. I think we have found about 30 or so. Most of them are listed, so we have actually cases, and I'm starting here from the top and not going all through those numbers and those names, but I want to say there are actually cases where de facto the situation is that we have really two de facto single stars because of very, very high separation of 200 to 500 AU, but the closest one are cases where the separation is about 20 to 30 AU. So say our Sun, one piece, Uranus, the other stellar component. So there's really some interaction, some non-triviality regarding orbital stability and habitability determination. Contribution from our group, from Arlington. So what we have done is actually a different type of approach, having them actually numerical tools online, which is that prior to any type of investigations, we do not need to make a decision whether we are investigating S-type or P-type habitability, putting in semi-major axis, putting in eccentricity of the two stellar components, putting in mass and luminosities of the stars, and then the computer tells us whether S-type or S-type situation is possible, P-type situation is possible, or none of the above. So, and this really requires a solution of a quartic equation, which we were able to do. So it's now BinHub 2.0. Can make a Google search using a cell phone, put in BinHub Arlington, and then this numerical tool is available in a straightforward manner. I have some examples here, and so some confusograms, and I don't want to go through all of those figures and so on. This would not be a good idea. But I want to say, as a general tendency, what is I like to form a negative statement. What is hurting the case of habitable zone is high eccentricity of the stellar components, low masses, low luminosity, and also what is hurting is if there is an imbalance regarding mass or luminosity of the two components. And the reason for this is, based on the model as used, planets, in order to be habitable, are expected to stay in the habitable zone all the time. So there are some other groups who have deviated from that concept. For instance, Siegfried Eggelwerher and his team, for instance, is calculating average type of supposed radiation of the planet, and this by regarding his models. Okay, planets are allowed to leave, re-enter. If they have a thick atmosphere, it means that habitability is maintained in case of the model we are using. So we are a little bit stricter, and that's actually an opportunity for future research, for future modification, for future upgrades. Okay, not going through all of those situations, but this is, for instance, a case where we study P-type and S-type habitability based on those generic parameters. And again, as expected, when the two stars are really close together, and this is really this bottom grayish area, a P-type habitability is possible if they're far apart, no surprise here. S-type habitability is possible, but there's also this wide range here. So there is a critical dead zone area where neither S-type or P-type habitability is possible. What is the physical explanation? Orbital stability, because if a planet would be injected in that case, due to the stellar parameters, even though the radiation budget would be fine, but the planet would not be orbitally stable. Therefore, again, based on this approach, identification is no habitable zone for this particular choice of parameters. Okay, and this is a more recent work, what we have done, where we also considered the mass of the planet. So there is a paper by Quadruple et al., 2014, and I'm sure Jim Casting, your co-author of it. Yes, and so it happens to be that based on the climate models, there is a difference regarding inner limit based on the mass of the planet. And if this is being used as part of the model for BinHub, it then turns out, again, there is, of course, a difference as expected for the habitable zone based on the planet as chosen. Okay, but I said more than 2 stars in the sky. I said the talk says multiple suns in the sky, and at that point it gives me reason to at least briefly talk about triple and quadruple systems. It's a paper which has just been submitted, and it turns out that there is a total of about 30 cases of triple stars with planets, about 30 cases. Out of the 30 cases, about 10 cases are controversial. If I would like to play safe on a Thursday afternoon, going down to about 20 cases, about 20 safe cases of triple stellar systems with planets. It actually turns out, few things I want to say, that all those 20 cases are highly hierarchic, because it turns out they are a binary on one side and a lonely wolf on the other side. So in some sense, if you're getting all those news, press releases, planet in the triple stellar system found, get even an article, first page New York Times, it's a little bit waggy, I want to say, because in fact, all those triple systems are very highly hierarchic binary systems, in the sense it's a binary and another single star at a relatively large system. Number of possible habitable situations. How many are they? If I can, well, I don't do the full math, so just think about carefully. Actually, it turns out the correct number is 4. So if you have a hierarchic binary, it could be an S-type orbit about one of those 2 stellar components regarding the binary. Then there could be a P-type orbit about the 2 stars of the binary. And of course, then there could be an S-type orbit about that single distant star. So having 4 types of situations, and from an counting point of view, those 4 situations have been identified. Another interesting point is, that's being shown here down under, that came to surprise to us. And I have to say, we are using other people's data. We are using data from the literature. These are not our observations, but it's our statistical analysis. I want to say, turned out that there is a relatively high percentage of A and F-type stars in those systems. Again, the majority is still K-type and M-type, but not as highly skewed as a number count for single stars in the solar neighborhood. So a relatively high number of A-type and F-type stars. That is what we have found. Cannot stop myself talking about quadruple systems. So we have actually listed here 4 quadruple systems which have been identified in the literature. One quadruple system needs to be dismissed because it turned out that one of the stellar components was actually a background star. So going down from 4 to 3. But also in those 3 cases, honestly speaking, that's not really true quadruple systems with planets there. All those cases are actually pairs of binaries. Okay, gravitationally bound binaries, and the planet is then belonging to one of those binaries. Okay, so we have some done by one of our students who's part of the paper, having a map here being drawn. And so we have those constellations, of course, and the different systems. You have color-coded the different level of certainty. And if I go next here, I think there is a, not surprising, this is a type of accumulation of cases which we have found. And but I want to say the best and highest accumulation of cases are actually associated with the results of the Kepler mission. So not surprising here. Well, I want to say, would like to give a little bit for the last 5 minutes or so, which I still have, I guess, a different angle of it by going back to the statistic and going back to statistic one more time. And want to say one statement I made is there's a relatively high abundance of A-type and F-type stellar components. That is just as being displaced by this bar diagram, but it's still the case that the majority of the planets are in conjunction with M-type stars. And this is a concern from the overall perspective of habitability study. In this case, I give credit to Edward Guyon, Villanova University, who has given me some slides because he is very interested for the last few years talking about living with a red dwarf. So what is the possibility, likelihood of habitability around a red dwarf, irrespectively if it is a single case, double case, or a triple case? And those are a few things which need to be mentioned at that point. So actually, this is a logo. I think it's not fully approved by NASA. So this is a logo he is using when he's trying to get some money. Most of the time he's pretty successful, I guess. So, okay, not fully approved by NASA, but maybe you see this around time by time. And here we are comparing different M-type stars. So this is our sun. This is a hot M, middle M, low M. And actually, it happens to be that in luminosity space, there's a difference between M-type M0 and M8 is actually quite immense. It could actually easily be broken up in 3 different spectral type classes, but it's not historically speaking. But this is another aspect to keep in mind. Question is, are M-type stars friendly or not so much with respect to offering habitability? And after a lot of discussion and review, both Edward Guyon and his group and myself, we became increasingly concerned. This is also, I want to say, triggered with respect to research being done for the Alpha Centauri stellar system, where a lot of papers have emerged. So this is actually the setup information about that system. So that's Alpha Centauri A, our sun. We have heard a lot about our sun today, so that's our sun comparison. That is Alpha Centauri B. That is Proxima Centauri. Proxima Centauri is an M dwarf, and that M dwarf is hosting a planet. So this is actually the announcement of that result done in 2016, almost 4 years ago. And this is what's quite interesting here. So we are comparing solar system on the left-hand side to Proxima Centauri on the right-hand side. And in this case, all scales are to scale. So we have our sun here, we have orbit of Mercury, so the habitable zone was just sometimes somewhere behind the wall, as expected. And here is the case of Proxima Centauri, so the star is practically not visible and very, very small. And this would be the habitable zone, which is size-wise between 10% to 20% of Sun-Mercury distance. So the habitable zone is small. The habitable zone is close to the star, as expected. Let's take another deeper look about the radiative environment. So based on data from Ribas et al. 2016, it happens to be that there is a significant high energetic flux. The next slide is maybe even better here. So what we do here is depicting the flux density on the planet in X-ray regarding Earth versus Proxima Centauri B. And it happens to be Proxima Centauri B receives about 250 times the X-ray of Earth, 50 to 30 times EUV, and 15 to 30 times far UV. what's the reason for this? The reason for this is twofold. The first reason is, of course, the habitable zone is much, much closer to the star. And the other point is M-type dwarfs are inherently much more active regarding X-ray, EUV, and FUV. And this is a concern. And I want to say that also prompted additional research by Edward Gein and myself, and we both are becoming more and more fans of K-type stars as being good places for hosting habitable planets with life. I know, of course, our sun is a good place, otherwise we wouldn't be here, but it's just one event, so we need many, many, and I hope this will happen at one day, finding planets with life that we have really good statistics in case there is in case there are additional planets hosting life. And I think the case for K-type dwarfs is pretty strong. They are relatively frequent compared to G-type stars, even though not as frequent as M-type dwarfs. Number one, stellar lifetimes are long, about a factor of 5 to 10 longer than our sun, which would be even larger than the current age of the universe. Which of a habitable zone is reduced, but on the other side, those stars are relatively frequent, so we have done a mathematical analysis which is favoring this opinion. Also understand that we are not the only one who are favoring K-type dwarfs. Jeff Linsky told me at one point he has similar ideas. Other people in the field along that line are, for instance, René Heller and his team at Göttingen, who also has published a previous paper advocating K-dwarfs. So there's a lot of interest in that field. One of the important points, and I alluded to this before, is really space weather research. And I've heard that NCAR HAO is very interested in space weather, just checking out how habitable zones are being modified by space weather. This is, let's say, analyzing EUV, FUV, and X-ray is a good start. Other processes of space weather are important as well. This again speaks against M-type dwarfs, but helps K-stars and helps G-type stars. And well, I cannot stop myself. I said, okay, let's go to the extreme case, septuple systems. So there are two septuple systems, AR Cassiopeia and US Scorpii. Is there chances for habitability? Want to say the answer is maybe yes. So we have to check out how those stars are those two stellar systems are composed, and it happens to be that both of those are composed by containing pairs of binaries. I want to say, and for any of those binaries, of course, there would be possibility of S-type and P-type orbits, but it needs to be really carefully evaluated because there are also some cheaters. I think one of the systems contains a white dwarf, which is also not a good place to live close by. I don't want to live close to a white dwarf, I guess. And another system contains some hot stars. But in principle, speaking from a generic point of view, if you're going really to septuple systems and the stars are type of well-behaving, there is a principal chance for habitability in especially under the special circumstances that there is structuring, that those systems contain both single stars, de facto single stars, and de facto pairs of binaries. So all that what has been said about binaries would be, at least in principle, relevant. Future projects. So my last slide is interested in advanced studies of habitability in multiple stellar systems, n greater than 2. Getting more interested in studying effects of UV, EUV flares, superflares, energetic particles. Keyword, make long story short, would be space weather. Observational data would be important. I think I learned that regarding TESS, a circumbinary planet has been discovered. I had been too lazy to update my slide, but I learned about it. And finally, also the entire notion of habitable zone needs to be revisited. If you're just taking the very standard picture after modifications, and when I say standard picture, I would like to point to that paper, Jim Casting et al. 1993, who also has hit about 1,000 citations right now. Updates have been done, modifications have been done, but also, of course, there is interest about how other greenhouse gases are shaping the concept of traditional habitability, and I'm pretty sure Jim Casting will talk about this. Another reason for me to stop now.
Thank you very much.